Hello and welcome. In an effort to rewrite the world in Rust, we're going to be making our own command line interface. We're going to be creating a ls command. We're going to be going through a lot of cool Rust crates and writing something to call our own. Let's get into it. As is tradition, we're going to do a cargo new. I'm going to call this best ls. Going to be the best ls. Let's cd into our new directory here. I'll cd over here as well. Now I should have the project set up here. Fire up our favorite editors, only NeoVim. Let's throw a fast fetch up there and we'll get started on the initial project setup. So the first thing, we're gonna slowly introduce crates as we go here. So we're gonna be starting with the clap crate. So I'm gonna add the clap crate here, version 4.5.39 with the derive feature. That's gonna be important. And this is gonna make it super easy to start parsing command line arguments and make this into a proper CLI app. And we can actually get started with that. So let's start with parsing the command line arguments. I'll create a structure here. We're gonna call this CLI, sort of how Clap names it in the tutorial. And to start, we'll be actually taking a path as the first as our first command line argument. And I can add the path buff here. All right, so now we have the path. I'll have to import that. And essentially the way this works with Clap is we're gonna be adding another section, another trait, I believe, in the derive section. Okay, I'll just do it manually with the parser, something like this. All right, next step, we're gonna actually be calling, I'm gonna create a new variable. I'll just call this let's CLI, and then make this equal to our CLI structure here. And now we can call the parse method that's been added from the trait that we added in the derive section. I'm actually gonna rename this CLI. And just with that alone, I believe we can already start seeing some of the functionality for our application here. So if I did like so I'm gonna do a cargo run. I have an alias here to make it called CR, if you're just wondering about that. But if I do a cargo run, I do a dash dash. This is how you can start giving command line arguments into your Rust applications. You can use the dash dash. And I'll just do a dash H. I believe it should start showing the functionality. Yeah, it did it. I'll just do that again. And you'll notice there's a little bit of verbosity here, but if you look down here, it actually starts showing like the help section that you would expect from a CLI. So it says like usage, best LS, the path, it even gives the name of the path, shows the argument section down here, and even an options section right down below to show the different options that we have currently available. So just by setting up this little section of code right here, we've already seen how like it's automatically generating the expected CLI functionality. Now we can actually go a bit further. I'm gonna change this. I believe I can add command, I believe it is. I can do CIB, I'll do a version, something like this. So now after adding the command version over here, I should already be able to see some of the functionality. If I do a dash dash version, when it's finished running, you can see it actually prints out the version right there. And if I run this again with the help command, you can see the version now is added in. The version flag is already added in. So, and all I had to do is just add a little thing right up here. So I'm going to be adding a few more things. We're going to add an about section. We're going to add a long, I believe it's called the long about section. Long about. It's going to equal, we'll call this, how would we describe this? Best ls command ever. All right, let's print the help section again. You can actually see right here, it actually prints out the long about section. So already we're starting to get a little command line interface here. And you know, we haven't really added that much code. So what's cool about Clap is it sort of does all the stuff for you, and then you can just focus on writing your program and stuff like that. So we got that. We got the about section. we're actually going to start parsing some of these command line arguments here, and we can just see how that works down here. So we're going to be taking the path from the CLI. So I'm just going to write let path, it's going to equal CLI dot path, and we're actually going to, this is an option, so we're going to unwrap this. I'm going to do an unwrap or, and if we don't get the path we're looking for, I'll just do a default path buff from. And since we're writing like an ls command, you know, let's do an example of the ls command. Let's do an ll, something like this. The directory, depending on the path that's being given to this command line application. So if no path is given, we're just gonna sort of default to the dot path, to the path sort of relative to the current directory. And I'm just gonna start printing stuff out. Yeah, let's add this in here. I think I can do a display, something like that. And if I run, so if I run a cargo run dash dash, and I'll just say long path, it should print long path right here. So yeah, we're getting the CLI argument. If I don't do it, if I don't have a long path, it's just gonna print dot. Let's just get this back at the top. Yeah, so it's just gonna print out the dot if we don't give any command line arguments. All right, and since we're going to be making a better ls, we better start filling out the blanks. So let's do an if let here. We're going to do an if let okay. So we're just going to sort of be reading the incoming path, and we can do that with Rust. There's sort of a method here. It's called exists, and as you might expect, it will let us know if this in fact exists. We'll add does exist here. How do I spell that? Does exist. And then essentially, if does exist, we're going to do something. And if the path that they give us doesn't exist, we are going to do something else. I think I messed up the wrong OK symbol there. Yeah, that's the right one. Start this off. We'll start with some printing. So let's drop a print statement here. If the path doesn't exist, we're just going to return, and I'm going to do it like this, as you'll see why in a second. Path does not exist. Okay, so now, just now, if I give it some long path that doesn't exist, let's get rid of this print statement down there. Do that again. Yeah, we're going to see path does not exist. We're going to be adding a crate. Let's jump over to the TOML. I believe it's the OWU colors crate. And this is going to essentially let us print out what we want with cool colors. So if I just sort of set this to red, try that again. And as you can see, it actually prints out path does not exist in red. And if I were to see, if I do a cargo, let's do a cargo build, just to see what that might look like. I'll do run best ls from here, give it a weird name, and you'll just see it pops out, path does not exist. So as an example of running the application from the target directory, when you do a cargo build in debug mode, it's gonna create an executable in the target debug location. Okay, now what if the file does exactly exist? What do we want to do then? I actually want to add another piece of this too. So this returns okay, only if it can actually read. Let's go into the documentation so I don't butcher this for a second. All right. This method will return okay if the path was verified to exist or not, if its existence can neither be confirmed nor denied. So we're going to have to sort of handle if the existence cannot be confirmed or denied. And I think we'll just kind of do the similar thing with a print statement, except we'll change the print statement to cannot determine, or maybe we'll call this error reading directory. I think I'm running out of ideas. Okay, so if it does exist, if the directory does exist, we're gonna want to start sort of printing the files out here. So I think I'm gonna do this in a few ways. Let's create a new method. We're gonna call this wrong snippet. We're gonna call this get files. And it will take, I guess we'll just take a path. We'll give this a path, and it's going to return, at the start, we're going to just return a vector of strings. And then we're just going to sort of expand this to something a little more appropriate for our application. And let's clear up some of these issues here. We're gonna make a new variable to hold our return data. Just gonna be a vector. We'll return the vector. And now we can start filling this out. So the way we can do this, we can do an if let. It's going to be another OK, but the OK is going to be for the file system read directory. We're going to give it the path that comes in. We'll call this directory entry, I guess. Or rather, I'll call this a read dir. And then we're going to loop through this. For entry in read dir, we'll do another if let here. If this is okay, if our entry's okay, I'll call this the file. And for now, what we're going to be doing is I'll just sort of push to our new data. We'll push to our vector. The file, we'll take the file name. We're going to do into string. This is should be an option, so I'm going to unwrap or. If we couldn't figure this out, we'll just do an into, and we'll call this unknown name. And this should quickly read the directory and push the name of the file into our vector, and then we'll return the vector. Okay, and we should be able to start the process of this. So let's do a for loop for file in get files with the path, I believe it is. Oh, we'll give it to ampersand. And for now, we're just gonna print this file to the console. Let's see what happens. It should in theory work. If I run a cargo run with nothing, it's gonna treat that like just this working directory, and it should print out everything like it did right here. Looks like it's printing everything out pretty nicely. All right, and now we'll be able to push forward. Now let's extract that precious file metadata and print it out into the console. So let's create a data structure that's going to hold the appropriate values that we need to sort of hold our metadata. Let's create a new struct. I'm going to call this file entry, mainly due to name fatigue. And we're going to be holding a bunch of variables for the metadata, a bunch of properties here. So we'll have a name, the file name. We'll have, I can't call this type. So we're gonna have the length in bytes. I'll start with this. So the length of the file in bytes, this should be a U64, I believe. And we'll have a modified string, which will just be for the date that the file was modified, the last file was modified. And we'll actually create a little enum. We're gonna do a little enum maxing here. Let's create an enum, and this is gonna represent sort of like the type that this file entry is, which is just going to be two different types. So let's just do an enum. I'll just call this file type, I guess, or entry type or something type. Okay, this type. And then the two types, we can be a file or a directory. And this is probably a good time to add the strum dependency. So strum is going to be used to max out our enums here. We're going to be doing God level enums, but yeah, so to start that off, I might as well just add this in, and we might not see this till a little later, but I'm going to add the display macro from strum, and this is going to let us just print the enum sort of to string. Okay, so now that I got the type, we're actually going to add that, maybe we'll just call this, I'll just call this e-type. Calling this e-type will let me demonstrate something a little later. And this is going to be an entry type, something like this, I believe. Okay, so we got the data type to hold our metadata. Let's modify our method here. Oops, went to the wrong spot. That's okay, we're using Vim. We're gonna call this, what did I call it again? File entry. Always forgets that. File entry. And we'll have to expand this out. We're gonna clean this up a little later, but this is gonna be a somewhat quick and dirty. So we're gonna be pushing a file entry, something like so. And I can grab this, put that here, I believe. Or rather here. Oops, lost my thing. Let's highlight that again, place that here, and I can delete that here. So that'll be the name. So we're gonna have to do this a little differently. So right about here, we're gonna drop another if let, And believe we're going to be calling it's the file system metadata, I believe it is. And we're just going to give it the same path, I believe also. But this isn't going to be some, it's going to be okay, I believe. And if everything's okay here, I'll grab all this, put it up here for now. And then I can start filling out the blanks here. I'm going to drop an if statement here. This is going to be requiring more cleaning by the second. Let's do an else block. So this, if, let's change the variable here. I'll call this metadata, or I'll just call this meta for short. And if meta is directory, we're going to return an entry type directory, I believe it is. Let's clean this up a little bit. Similar to this, but this is going to be a file if it's not that. Length in bytes, this should just be meta.length. And we're actually going to hold the modified just as a string for now. This is going to get changed really quickly. I just need a placeholder for now. And since this is now returning this type of thing, I think we could just pretty print this out for now. Why isn't I think I could just pretty print this. I forget how to pretty print. All right, it's quick and dirty. We're going to clean that up later. But now we should be able to extract the metadata. And we're just going to kind of print this out in a big mess right now. All right, let's just expand this. Okay, so we can sort of see it starting in action here. Except I think it's not getting everything correct. Yeah, looks like something's not right. Oh, that explains it. I gave it the wrong thing. I gave it the path. I wanted to give it the file here. So it's path, I believe it is. Okay, that looks a lot better. So you can see the length in bytes. Let's make this at the top of the screen. It's easier to read. Okay, it's a bit verbose, so it's just going to push us down here. But as we can see, it's sort of starting to give us, it looks like the metadata. Like it shows this is a file, 225 bytes. Looks like we're starting to get what we need here. Probably a good time to clean this up. Since it is sort of working, I can extract this into a function for now. Not that part. Wanted to extract actually here. Extract that into a function, a little cleaner. I'll call this map data, I guess, just because it's kind of mapping the data. I don't know. Name fatigue. Try this again. Let's see if it's still working. Still printing. Good. All right. This is a good start. It's a little messy, but now we're going to make this print out really nice, really cool looking. We're going to be adding yet another crate. We're going to call this, well, this is called the tabled crate. This is the tabled crate. So what this crate is going to allow us to do, and you are going to see this pretty soon, it's going to allow us to print out our file entry here in a really nice looking ASCII table. So to get that set up though, I have to add, I believe it's up here. We're going to be adding something. It's called tabled, I believe. Tabled? Okay, so we add the tabled method to that. And then I should be able to come down here. And instead of doing this loop, what I'm going to do is I'm going to pull this into a separate variable, the get files. We're going to create a table. I'll call it just table, I guess. Table from our new crate. I should be able to give it the get files. I can get rid of this. And we'll have we'll change actually the print statement to print out the table. Just like this, something like this, I believe. Now, quickly, if I just print this out. All right. As you can see, we've already started to get a little bit of formatting here in our printing. And it shows the name, type, length. And we're going to be going into making this just a little better. So I can actually call on this table variable, I can call width. I believe it's width. Style, and let's try, did I use the wrong style? I did. Jump down here again. It's gonna be a style from, it's too many styles from here. We're gonna do a rounded, I believe. Let's see what this looks like. All right, I kind of like this one a little better. All right, it's kind of starting to look like the new shell printing. Well, let's update this just a little bit more now. So we've added the style. I can do a table dot, oops, spelled that wrong. Table, modify. I can target columns. I can spell. I can target columns. I can target the first column. And what I'm gonna do is we're gonna add a color to this. We're gonna add colors. I believe it's this one. And I'm gonna do a foreground. Let's do a bright cyan. Something like that. All right, let's see what that looks like now. Okay, now we're getting some color into our table. Let's add a few more colors. Start with this one. Add one here because I'm gonna have to choose like the second index column. I'll change this to FG Bright Magneta. Let's jump over here, change this to 3. We'll make this bright yellow. We'll go yellow, I guess. And then, oops, I just broke. Then change this. We're gonna target the first row of this table. And we're gonna make it, I wanna make it bright green. All right, let's see what this is gonna look like. Much nicer, starting to look much nicer. Nice, well-formatted table. Didn't really have to add much code here. Let's get a little bit more advanced in this crate here. I believe what I can do, we can add a, I believe it's called the tabled. I can rename certain. I can rename these as I need. So we'll call this type, call this name. I think that should work. Yep, you can see now the headers. It says name up here, type. Let's call this size, and I'll just go bytes, I guess, size B. Okay, now we're starting to get a better LS. We're starting to get a better LS, so much better. Now let's do something about that modified column. We're gonna need a crate, something to give us the ability to handle time and dates. And a perfect crate for that is the chrono crate. So we're going to be adding chrono to our TOML file. We're going to head down into our map data section where we map the modified section here. So what I want to do here is I'm going to do a if-let. We're going to do an if-let. This is going to be an OK. We're going to do an else block also. If we can't tell the modified when it's going to be modified, what we're going to do is we're just going to drop sort of an empty string here. I'll pull this up a bit, and if we can tell if it's modified, I'll change this to mod. We'll have to change this also to meta.modified. This will give us an option or a result with the system time. This is going to be a result with the system time. That's why we're adding this crate. We're going to be using the datetime class from this crate, or struct, I should say. We're going to add the UTC thing sort of in here. Then we're going to do this is going to be mod.into. Should be just an into, something like this. Check this out. I'll call this modi because it doesn't want me to use that keyword. And we're going to be returning a string with a special formatting. It's gonna kind of look like this, date.format. And we're gonna give it a string, which is gonna sort of print out the date how I want it, which is gonna be kind of obscure. There's like a bunch of symbols here that you use to print out different sections of the date. Oops. Let's just handle this. What was wrong here? UTC, we got the import. Should be good now. Let's do a cargo run. It's gonna compile. Almost got it, but something, oh yeah, I think we just made this today, right? So that should be the date. I think that's correct. But as we can see, we're now getting that printed out. Although I did screw up the colors here. I didn't notice. I want to change this to, let's change this to like a bright, what was it? Yellow, I think. I wanted bright yellow. Yeah, that's better. Yeah, I'm a yellow fan. Okay, cool. So now we've got like a little better LS. So let's just, if I give this a path to the source directory, it's going to print what's in the source directory. So that looks pretty good. Now let's add a little bit to our command line interface application here. So if I do a -H, we can see our options. It's really just the path, help, and the version right now. I want to actually add another option into our CLI, and then we can kind of show another cool crate. So we're gonna add, I'm gonna call this JSON. We'll add a Boolean here. And if I do the help again here, that's because I didn't set this up right. So we actually got to add some of the clap stuff. So this is going to be an arg, and you're going to put short, long. So there's a short and long version of this argument. All right, now we can see it's starting to come up here. -j and --JSON is another flag that we can add in. Let's clean this up a little bit. Let's do a VIB. I'll call this, extract that to a function. Rename this, Control F, CIW, print. I'll call this print table, a decent name. And here we're going to do another if statement. And basically, if CLI.json, that's going to be the field up below, we'll do something. And if not, we're going to do something else. The else will be the print table. So what are we going to do if we have the JSON? Well, we're going to be printing out our whole file system or all that metadata as JSON. To do that, we're going to need another crate. We're going to be adding 2 CERD crates. The CERD with the derived and then the CERD JSON crate. And this is going to give us the ability to serialize this data into JSON and then print it out to the console, which is very lovely. So I believe I can just add the serialize function here. It should yell at me because I don't have it here on the enum either. So now I have it there. And if we do the print JSON, let's do a print line. Oops, forgot the thing. And we'll call the CERD JSON module. I'm gonna toString. Oh, I did this kind of wrong. So just quickly, I'm just gonna call get files here. It's a bit duplicatey, but that's just what we're gonna do for now because I kind of didn't refactor that 100%. And I believe I can drop something. And so we're going to do an unwrap or, because this is going to return a string. And if it can't really do the right string for now, I'm just going to sort of make it give us a string that says cannot parse JSON, just for now. Okay, so if I just run this normally, so let's just load up. If I just run this normally, we'll get the table. But now if I start giving those flags, so I can do a -j. And boom, it's actually going to print out a JSON representation of this. And I can also do a dash, get my thing going, --JSON, and it'll do the same thing. And as I do the -- help, you can see we got the JSON, -j, --JSON. So now we have a little example here of a little command line interface that I can use to sort of print out the file system. Let's do the source directory. Yeah, so now we've made our own little ls command. Oh, looks kind of weird when the font's too big. But yeah, now we have our own ls command. And we had a good chance to walk through a lot of different cool crates. We got the JSON crate, the Chronos crate, clap crate, our little colors crate. We got strum, the tabled crate. All of these just super easy to whip up a little nice command line interface application. If you did enjoy the video, please consider giving a like and subscribe. It really helps out the video and helps support the channel.